Now, whenever we're making slime, we basically need various ingredients. So one of them is a slime activator. So you can buy this from me on my website, or you can go to any other website or store to get the slime activator. You'll not get it as cheap as the one from me, because I don't want to be spending and wasting lots of money on an activity that the kids are going to do again and again and again. So you're going to get powders inside the bottle, and once you've topped it up with a litre, you'll kind of use it all up, and then I have got another sachet which will allow you to make a further litre of slime activator. And all you have to do is add it to, obviously, 1 litre of water. So we're going to put that in there. So I can be kind of messing about getting my slime activator activated while we are, oh, I've got a hi nanny there, that would be Maya. So we're stirring away, a bit like a witchy, woohoo! Here we go. Now, stir that into a little bit of lukewarm water if you want to kind of use it immediately. So I'm stirring away here, and what we've got now is an opportunity to talk about dissolving. And whenever we look at crystals, there are lots of tiny, tiny molecules all joined together, or atoms joined together, and there are bonds there. Some of those bonds are really strong and it's very difficult to pull them apart, but others are a bit weaker and it's much more easy to pull the atoms off. And what we need to pull them off is a force. So whenever we've got water, the molecules are moving around and they bash into the crystals, and they cause little bits of the crystals to come off until eventually they mix in with all of the water molecules. So you can try it with salt, you can try it with sugar, and then you can kind of look to see, well, if we heat up the water molecules are going to move faster. They're going to attack the atoms much faster. If I stir, this is what I'm doing, I'm going to speed up my water molecules, and then hopefully that is also going to allow us to speed up that dissolving process. Okay, now that's taken ages. I'm going to cheat here, and I'm just going to pour it in like that. Steady hands needed here, steady hands. And what we want to make sure is all of those crystals have gone in. Now, whenever we're using our slime activators, we've got to make sure that our hands are nice and safe. So we want to be using liquids which are not too acidic and not too alkaline. So the first thing I want to do is to share with you a nice and simple way that we can test the acidity or the alkalinity of our materials. So I'm just going to move that over there. So this is my slime activator. I'm just going to put the lid on there for the moment. And so what I've been doing, Eleanor, what do you need? Eleanor's just said, what do you need? So this is what I'm going through at the moment. So the very first thing we need is our slime activator. So I'm just talking about that at the moment. And then, so we were here, then what we've got is I've got some cabbage. So I've boiled the cabbage. Here we go. So there's my cabbage, and it gives me a wonderful purple colour. And I'm going to pour some of this juice into 3 beakers. I'm going to use my tea strainer so that I can make sure there's no cabbage going in there. Look, lovely purple colours. Actually, it's very deep purple. Now, there we go. So we've got that there. And I'm just going to add a little bit more water to that so it's not just as dark. Now what I've got here is some baking soda, and when I put it into water it's going to give me an alkaline solution. So in my cabbage juice I am going to go from purple to blue. There we go. So we've got that nice blue colour there. And if I kind of pour some of that water off, pour some of this water in, and so the colour's not just as dark. Oh, look at that, that's nice. That's a nice blue colour. So I'm going to do that again, okay, just to kind of dilute my cabbage juice. So what I've got then is I've got this liquid for the cabbage, and inside it there are pigments. So many years ago, thousands of years ago, we would have used plants to dye our clothes, and cabbage would have been one that they used. And if they put baking soda into it, it kind of gave us a lovely blue color, and we get red if we put it into vinegar. Now what I want to do is I want to test our alkaline solution. So this slime activator is going to be slightly alkaline. Okay, there we go. And it is pretty much the same alkalinity as baking soda. If it was stronger, we would then go into greens, and if it's deadly, it kind of goes into yellows. That's other videos. So it's not just as strong, we've still kind of got that purple tint there. So I'm going to get rid of all those. So the slime activator is going to be nice and safe for our hands. We don't have to worry about that. So that's all gone in there. Brilliant. Move those out of the way. The next thing we need is going to be our PVA glue. So I've got two examples here. One is a clear glue, and one is, oh, hang on a minute, I've got somebody saying they're trying to see the show but they can't see it. So you're going to go, I don't know, go on to Science to Life page. I should be going live there. Can someone give me a thumbs up to say we're going live? Oh, thank you. We're definitely going live. So I don't know what the problem is there. Now, last week I tested these, and I used one of the glues from Poundland, nice and cheap, but it really doesn't make a good slime. So I got these in Tesco, and we can get measuring cups. So whenever we're making slimes, it's a really nice opportunity to get the children to be measuring. So we've got different measuring cups here, different sizes, etc. So what I'm going to do is I'm going to make two different slimes using two different glues. And I'm going to use just 60 milliliters. Now watch how slowly that flows. Can you see that? How slowly? I have to really kind of give a big push in here to kind of get this to flow. And the reason for this is it is a special liquid. It's called polyvinyl alcohol, PVA. And that word poly lets me know that this material, this liquid, is made up of very, 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 that sounds disgusting, long chain molecules. And so we can then introduce a word called viscosity. Oh, I like that word. Give me that word. Viscosity. Here we go. So it's actually the reluctance to want to flow. Okay, so there we go. So water flows really easily, so it's got a very, very low viscosity. But this mixture here, this liquid here, is kind of thick like honey. Okay, right, so move that there. So let's kind of have a little look at this. So what I've got is some Christmas beads. So you can get your old Christmas beads out, and I've got them into a beaker. Well, oh, that nearly went there. And look, long chain molecule. And so whenever we've kind of got these molecule beads, they kind of give us an idea. Each bead is one molecule, and they join onto another one, and another one, and another one, and another one, and another one. And you don't have to have the science gear, okay? So what you can do is you can just use your normal glasses at home, a fishbowl, and there we go. A lovely long chain molecule. And there's going to be kind of forces between these molecules as they're trying to flow, frictional forces, and as they kind of move over each other, it kind of makes it much more difficult for it to flow. So that's why it's a little bit more viscous. This isn't the slime though. To get the slime, we have to add more bonds to get those to kind of join together a little bit more. So I've got my glue there. And so in the kit, you're also going to get a little measuring cylinder or measuring cup. So what I want to do is I want to measure in 20 milliliters of water. So you can use cups like that, or you can use spoons. So we can measure with all those going in there. Now the colour's a little bit boring, so I'm going to put in some yellow paint. So what we've got here then, this is it. This is the basics of our slime. PVA glue, the better quality glue, the better slime you're going to make. We've got paint or any food colouring to kind of give it some colours, and we're going to have some water, and it's the water that you can experiment with as well. So the more water we add, the more slimy it's going to be, a bit more like the kind of disgusting snot you get from your nose, and the less water we put in, the more kind of viscous it's going to be, and maybe even bouncy. Right, so I'm going to stir this up. I got Alessio and Donna, welcome. So I'm going to stir this up, but we've still got a fluid, we've still got a liquid, nice and thick, that word viscous, okay? So they've not been bonded together. So this is where we're going to use our slime activator. And so when we add the slime activator, we kind of add small amounts at a time. So also in the kit, I'm going to put in 2 of these little pipettes. But what I'm going to do here is I'm just going to pour it in. So I've got my little measuring cup there. There we go. And when I put it in, it's not going to join immediately. So this is the fun part. It does get a little bit thicker. So look, oh, we can see it's getting thicker there. Okay, but what we want to do is want to keep stirring it. And we're going to stir and stir and stir and stir, keep stirring until it starts to come away from the edges of the bowl. So at the moment, it's not coming away from the edges of the bowl. And if you like this kind of process of kind of seeing it kind of develop, you can just only add small amounts at a time, and then this whole stirring process will take for ages, forever, and that'll keep them busy. Now, so it's hard work this, sitting down. Now, we're getting there. Oh my goodness, now, if I go slowly, it's really easy to get my spoon to move through it. But as I go faster and faster, it gets more difficult. And this is why we call this material a non-Newtonian fluid. So Newton, you might not know about him because he's dead, he died a long time ago, but very, very famous scientist. And he studied fluids like water, and he came up with all these laws about them. And if I kind of stir water really fast, nothing really happens to it. But as I stir this material, it gets thicker and thicker and thicker. And if I treat it gently, well, it kind of flows like a liquid. Oh, hang on a minute. We're nearly there, we're nearly there. Now, oh my goodness, can you see that? It's starting now to come away from the edges of the bowl. Excellent. We have now made our slime. Now, whew, this is good. There we go. Isn't that great? So we can kind of play with it in our hands. Now, so we're going to give you a couple of hacks here. If you find when we're playing with this, it's just like I just sneezed in my hand, isn't it? Couldn't do that with COVID-19 going on. Look at all the germs that could spread there. Look, if I kind of treat it slowly, it's just going to kind of stick there. But remember, the more force we put there, then the more like a solid it behaves, and it's easier to get off the hands. If, however, it's still a little bit sticky, then what you can do is just add a tiny more amount of your slime activator. That's going to make it easier to pull it off. Or you can just add some baking soda. Now, so what we've got here then is we've got a material. When we treat it gently, it flows like a liquid. But if I treat it rough, it breaks like a solid. Now, what we can do at this stage then is we can experiment a little bit more by adding in some more materials. So lots of slime recipes are talking about putting polystyrene beads in there, putting glitter in there. What I want to do, oh, it's a bit messy, is I want to kind of look at some foams. Before we do this, I've got a cloth here. What I'm going to do is I'm going to put some of my slime on this cloth, okay? Now, when the slime goes on the cloth, there we go, Let's say it's on your carpet, it's in someone's hair, it's, you know, it's gone all over the place. Because of the way it moves, it is going to flow, oh, here we go, through all of the fibers of your material. It's a bit like chewing gum. Chewing gum is a slime as well. So whenever chewing gum goes on the streets, then what we're going to find is the chewing gum will start to flow in through all of the gaps that we have in the paving. And so when the council comes along to try to clean it off, they can clean it off. They'll be able to remove what's on the top using all of their science. But once they've removed it, we're still going to end up with that disgusting mark underneath because, oh, look at that. It flows into the pavement. So as it's a slime, I'm covered here, as it's a slime, it's also going to flow in your carpets, etc. So this is why I always say, always do these experiments outside. Now, before I kind of show you how to remove this from the cloth, I want it to kind of flow more into the cloth. I'm going to change the color of this slime. Now, I'm going to, try and get as much of that off my hands as possible. So we've got different foams. Again, you're going to be able to find these on my website, sciencetolife.com, or lots of supermarkets and things are selling them now. Inside there's a canister. It's filled with butane gas. So it's very, very important, no matter what we're looking at, that we check the safety symbols at the back. So with my science activator, I've added chemicals in to make sure it's safe for everyone to use. This one here, it's flammable. So whenever we get the bubbles, there we go, that's great. All of those bubbles in that foam are filled with butane gas. So we don't have any heat source near the kids or near us whenever we're playing with this foam. But the really cool thing is it bounces, this is cool, and it comes in different colors. And also at this time, when we're trying to encourage everybody to wash their hands for a long period of time, it actually takes a little bit longer to get the foam off of your hands than it does the kind of the soap. Also, if it's got different colors, then that color, there we go, that color is going to stain the hands a little bit. So we're also going to need to make sure we get rid of all the blue color. But I'm putting that into my slime. So I started off yellow, there we go here, and there we go. Look, as I start to fold this in, okay, so what we're going to do is what we're going to do, look at this, we're going to mix these in, and it's gone green, look at that. Okay, we've got purple foams, we've got pink foams. You can just add the foam in and it's going to change these wonderful colors. Now, let's get rid of that bit there. So what I've got now is I have got the slime, can you see that, on the cloth. And what we've got here is we've got a material, and the bonding is kind of down to do with kind of things that are positive and negatively charged. And we can interfere with that bonding, okay, we can interfere with it if we put in acids. So we've got a couple of acids that we could use. All of us will have vinegar, I would imagine, in our cupboards. But if you've got citric acid, you can use that as well, because citric acid is not going to be just as smelly as our vinegar. So I'm going to split my slime into two. So there's one there and there's one there, and I'm going to put the different acids on. Unfortunately, I forgot to bring the acid with me, so I just kind of got this classic cider vinegar. Let's put that in there. So that's gone in there, and I got some citric acid here. So I'm just going to put a few crystals of citric acid there. It looks like salt. Yeah, but it does not taste like salt. It is very, very sour. So you'll find them on the sweets oh, those sweets called sours and things. Oh, that was disgusting. Now, if I just kind of start to stir this, I could stir that with a spoon, but what I'm going to do is I'm just going to use my fingers. And all of a sudden, this material is breaking up. Okay, can you see that? And we're going to go back to a liquid material. If I go into the citric acid, I'm going to stir that in. Look at that. So as soon as it kind of goes in, those acid molecules will interfere with the bonding, and we've gone back to being a liquid. So that means if we end up getting slime on the surface of a material, well, the first thing we could do is, I suppose, kind of try to scrape as much of it off as possible. The firmer you are with it, the easier it is to be able to get it off. But what we can do, let's kind of put that disgusting stuff there, is treat the surface with some vinegar. So I'm going to put the vinegar on there now. Now, boys and girls, mums and dads shouldn't be doing this. Slime is for outside. But I have heard some parents tell me that some of them decide to take it to bed and hide it under the pillowcase, not realizing, I know, what a weird thing to do, not realizing it's going to flow everywhere and cause a disaster. But don't worry. It will kind of wash out in the washing machine, but you can't put your carpet in the washing machine. And look, already just a little bit of vinegar on there, that has started to break down. And all you're going to need then is a little brush and some soapy water, and that's your slime gone. Big slime hack there. Children, don't worry, because I can put in some baking soda. That baking soda is going to react with my acid, and it's going, oh look, and it's going to fizz, but it's going to allow me to get back to my slime. So I'm going to keep stirring there, keep stirring all that reaction, oh, going over there, add a bit more in. So as soon as I've reacted with all of the acid and taken away those charges that interfere with my bonding, I should go back to my slime. Let's have a bit more in there. So I'm Scientific Sue, and we have been playing not just with slime, we've been looking at solids, liquids, gases. We've been looking at acids and alkalis, and we've been looking at the idea of how we can introduce measuring. So this is a big load of baking soda for me. I forgot to put the citric acid in. So we're going to keep putting our baking soda in, because I want you to see that I actually do go back to slime. At the moment, it's just a big, complete mess. No. Well, that was a disaster, wasn't it? So whenever we're playing with slimes, outdoors, in the bathroom, in the kitchen, where if it does drip, it's not going to cause any damage. We can add lots of different things into them. Foams, they're really good fun. We can also maybe try the cabbage juice, because the cabbage juice changes colour. So soaps are alkaline. Do we go from purple to blue? Don't know. We're going to leave that one for you to find out. But don't forget that this material, okay, oh, look at that. This material is super special because it is a non-Newtonian fluid. It disobeys all of the laws of fluids that was studied many hundred years ago by this scientist called Newton. Treat it gently. It's got a low viscosity. Treat it rough, add bigger stresses to it, it is then going to act like a solid. Now, I'm Scientific Sue. I have managed to make a huge mess in the living room. But it's okay, because of the floors covered, and I'm going to make sure there's no messes left, because if there are, I can clean them up. What can I use? You're right, I can use the vinegar. Now, for those of you that are on my Scientific Sue page, you would have seen earlier that I did a couple of Diet Coke and Mentos hacks. Hack number 3 is coming up in about half an hour. So thank you so much for watching. Enjoy your slimy sessions. Make sure you play safe. And if we've got really small ones, sunglasses, just to kind of cover the eyes in case there's splashes. So again, thank you all so much for coming to join.